Hello, everyone, and welcome to another episode of the VMblog Expert Interview Series. And today we're welcoming back Liran Haimovitch, the CTO of Rookout. It's great to speak with you again.
Hey, David, it's great being here again.
For the folks who may not know or haven't looked at one of our other previous videos, if you could, maybe just give a quick overview of the company.
Of course, so Rookout is a software development company. What we do is we build developer tools, and especially observability tools for developers. We focus on providing developers the data they need to get deep insight and truly understand their code as it's running in remote environments. This can be anything from a development environment, staging environments in the cloud or on-prem, and all the way to production. We focus on bridging that gap between traditional observability tools that are, production grade and cloud native and get you tons of data, but they don't usually give what developers actually need. And we bridge that gap. We bring a much more an experience that's much more attuned with the needs of a developer, that's much closer to what local debugging would look like, except we allow that to happen in the cloud, we allow that to happen in production, anywhere you have code running, essentially.
So that's a great point. When we think about traditional observability data, we're usually talking about metrics, logs, and traces. But Rookout's saying there needs to be a fourth pillar of observability called snapshots. Can you explain what snapshots are and why they're needed?
Of course, so snapshots are about capturing the state of the application in a much more wholesome way than just grabbing a couple of variables and pushing them into a log line, or capturing them into a metric or a trace for that matter. Now, if you mentioned the three pillars of observability, the three pillars of observability have evolved mostly by SREs. We've been doing a great job at scaling systems and managing complex systems. Metrics have been around for a while, and traces have launched, especially with the rise of service meshes, cloud native architectures, and so on. But all of that comes from the big picture, from what SREs are looking at. Is the system up or down? Do I have a malfunction somewhere? Is there something wide going on? Developers, on the other hand, tend to ask much more focused questions that are focused on the nitty-gritty details of how a certain function works, how a certain service works, sometimes even focusing down to a single line of code. And for that, we've learned that logs and let alone traces and metrics don't provide the level of fidelity you would need. If you are looking at a log line, you have some text message somebody wrote. If you are lucky, they bothered throwing in 2 or 3 extra variables, and that's about it. You don't have a broad view of all the local variables. If some of the variables are more complex, let's say it's a collection or an object, it's going to be much harder to stringify it and push it into the log line, so you might have to do without it. And that's even before asking about other stuff. Do I have the stack trace? Do I have the global? Do I have the global variables? Do I have context of sorts? And all of a sudden, when you look at a single log line, especially as an engineer, it's telling you a very, very, very small part of the story. Now you can try piecing it together. You can try piecing it together by using multiple log lines. You can try piecing it together by adding more and more variables to log lines, but it really doesn't scale. It takes a lot of effort, and you're still going to end up with partial information. And what we found is that it's much more efficient to have a machine capture the state of the application. And I know snapshot sounds awesome and brand new, and it is in many ways, but it's also very old in other ways because, kernel dumps and core dumps have been with us for decades. Whether when a machine crashes or when the operating system crashes or when a process crashes, we've known that the most efficient way to identify those crashes, to identify those bugs, is just capture the whole state of the application, take a snapshot of it, and then send it to a developer so they can investigate it. And more often than not, it's a much more efficient approach than trying to dig through log lines or metrics and traces to go through the history and figure out what happened and how. And so we find that those same snapshots in a much more modernized and streamlined fashion is the best approach for how to provide developers insight into their code in the cloud as well. So whether you're looking at lift and shift, whether you're looking at cloud native, Kubernetes, serverless, you can benefit greatly from giving developers access to those snapshots of really how the application is behaving and how are things happening right now.
Now, it seems to be part of the shift left observability that Rookout, you guys have been talking about for a couple of years now. Can you talk about why traditional observability tools don't always meet the needs of developers?
So I think with traditional observability tools, there are a few key challenges when it comes to developers. The first I would say is around training. Developer observability tools were meant for people who are spending all of their days doing observability. Reading time series data is not that trivial, and figuring out how to divide it across dimensions or compare various metrics can get even trickier. Spans and traces are even more complex. And in many cases, even using logs is not trivial, especially when you're trying to do complex queries or complex comparisons of sort. And if you look at most large enterprises, you would find that there are observability teams of sorts, because this knowledge is very hard to come by. It takes a lot of training, it takes a lot of know-how. It also takes a lot of time to maintain, to keep up with the changing system, with the changing data. And so you find yourself with a centralized team that is in charge of observability, that's key at analyzing it. And what I've seen and heard pretty much everywhere is that, the day-to-day engineers, the most individual contributors, don't have the know-how to deal with those fairly complex systems, because it's not their day job to do observability, it's their day job to write code, and you want them to do some observability. The second challenge I've seen is that developers tend to get different tasks every day. Now, if you look at SREs, they mostly look at the very similar tasks when it comes to monitoring. Is the system up or down? Are specific services up or down? Are specific endpoints up or down? What's my request per second? What's my error rates? What's my latency? If you can answer those questions for your various components, you are 90% of the way there from an SRE perspective. A developer wouldn't care about that, because for the most part, developers don't care about the uptime of the system day to day. They don't monitor SLAs and SLOs. They get, development tasks, fix this bug, enhance this feature, deprecate that feature, design a new feature. For those questions, for those tasks, you need different pieces of data every single day. So I need to deprecate this feature. Is it currently being used? How is it being used? I need to fix this bug. How is it happening? Where is it happening? I want to enhance this feature. Is it being used today? By who? And so on and so forth. And each of those questions, because it's a new question, I'm going to have to figure out how to answer it from the start every day. And potentially, more likely than not, I'm going to want different data. Today, because observability tools offer the same data day in and day out, what happens more often than not is that the engineers spend their time reverse engineering and working backwards from the data that happens to be there into trying to answer the questions, instead of being able to just say, so I've got a new question, this is what I would want in the code to answer it, let's just instrument it, let's just create new observability data on the fly and answer the question with essentially zero effort, without all the guesswork and fancy stuff. And last but not least is about the complexity of the amount of data being extracted, kind of bringing us back to snapshots. Because if you look at SREs and other consumers of observability data, whether it's IT, security, and so on, they get the data very that they've asked for in a way. If you look at even if the famous Apache access logs, it's the same access logs for 30 years. You know what you're getting. You're getting the status code, you're getting the URL, you're getting the time spent in the request. You know what you're getting, and you don't care about how is it in the code. Somebody already extracted the relevant data for you. And then you as an IT guy, as an ops guy, as a security guy, you just care about the output. Somebody did all the hard work of extracting the relevant data and providing that to you in a format that's well known to you in the context you're operating, in the system you're operating. And for developers, because of the things I've mentioned, it's very different. They don't care just about those prefixed and pre-digested outputs. They want to define new outputs every day, and define those with logs can be very, very, very cumbersome. I mean, there are endless ways where things could go wrong. Think about even strings. You're seeing a string, how is it encoded? Just because the log file is encoded in a certain way doesn't mean the original string has been encoded in the same way. And you can often, without even knowing it, lose fidelity. The original string was encoded in a UTF, in Unicode, but the log file is in ASCII, and all of a sudden I've lost fidelity. And in some transformations, I might not even know it. And when I'm seeing 5 in the log, is it a string 5 or is it a number 5? Is it a float 5? Is it 5.0? Is it a character 5? Does it even matter? Is it the same for different languages or not? The same goes for objects and large collections. It gets very messy trying to do all the legwork of extract me this and extract me that and extract me this. Using snapshots, which is a very different approach, you can just say, grab me everything, and here is a tool that will capture the data while maintaining fidelity, while making sure that everything is well aligned.
So that's a good point. Thinking about both snapshots and logs. If a snapshot captures all the data needed when something unexpected happens, does that mean that logs will eventually become unnecessary, or do you see logs and snapshots as equal partners in the observability?
So I think logs have their place, but at the same time, I think that over the past years, we've seen actually a huge reduction in how logs are being used. Now, obviously, the log aggregation companies are making tons of money. So as a whole, the industry is making way more logs and paying tons of money for it. But I think as a fraction of the overall observability data, we don't rely on logs events as much as we used to, because we found out that for many cases, metrics and traces offer superior performance. Metrics in particular are way, way, way cheaper to generate, to process, and also, which is sometimes even more important than cheaper, it's much easier to create a real-time pipeline for metrics compared to a real-time pipeline for logs. You can generally see pipelines, metrics within seconds, sometimes even less than seconds, already calculated into a time series database to capture stuff, while for logs, it would probably take longer to process the data and make sure it's up to date, especially if you're using log file shipping and those sorts of batch processing that can take a while. And so as a whole, as the industry, we've learned to come that even though we all started with logs early in our, hello world days, we've moved on and now we've diversified. And we're not, and from an event perspective, logs are only used some of the time, and we're zooming out in many other cases. And I think just the same, we're going to find that snapshots are reducing the need for logs even more. Logs are going to be super useful where audit is required. You need to keep track of things for security, for compliance, for operational reasons. Then for audits, logs are great. It also fits very well to what we've discussed around the well-known structure of logs, because you've decided something needs to be audited. You've defined what's the event and which fields needs to be audited. So that's a great fit for logs. But when it comes to, keeping track of the application flow as a whole, logs are very inaccurate, in a way, very freestylish. And snapshots are doing a much better job taking care of that very accurately and giving you a much better picture. And so I think while logs won't disappear, I think developers are going to use them less and less. And I think that snapshots are going to offer much superior experience, efficiency, cost compared to those logs. And bringing us back to something we've seen, that even if you do need those logs, as I mentioned, for operational reasons and audit logs, you can often keep those logs in cold storage. And as I'm sure you know, part of the reason logs today are so expensive is because we spend so much time and effort on processing to index them, to keep them very easily searchable. That's even costing us tons and tons of money. Now, if you only keep those logs for cold storage and you rely much more on snapshots for analyzing and for development work, then you can save even more on the logs.
Now, finally, I want to pivot for just a moment because I know Rookout is going to be at KubeCon EU, which is coming up pretty quickly. Can you talk about how Rookout helps Kubernetes users who may be watching this video?
So I would mention that almost all of our customer base is cloud native. And while we do have a few of my favorite customers are still doing more traditional stuff. We have a couple of customers doing a Java Enterprise Edition. We even have one of my favorite customers is a storage company that deploys us over 5,000 bare metal machines. Most of our customer base are cloud native, the vast majority of which are Kubernetes based. Also, we have a lot of serverless customers, but focusing specifically on Kubernetes, one of the things we're seeing that when moving to those cloud native architectures, it becomes much harder to run things locally. As much as the paradigm is that you want every service to be standalone-ish and test everything with unit tests, this only goes so far. Sometimes you get it right, and that's awesome. I'm proud of you. But oftentimes that's not so easy, whether it's because you're migrating something, whether it's because somebody else's fault and they messed things up and the domain design is wrong. Maybe the bug just doesn't reproduce in the unit tests and whatever is happening. And so what often happens is that you need to run multiple services. Sometimes they use different runtime versions because you are looking to be polyglot. That's part of the charm of Kubernetes and containers. And all of a sudden, it becomes very, very, very messy or next to impossible to run things locally on your machine. And what we see most customers migrating to development clusters, whether those clusters are on their own laptops or more often in the cloud, you are deploying your code and you're interacting with other services. In the cloud, you are interacting with other services that are maybe provided by your cloud providers, such as databases and queues. And it's not so easy just debugging with your ID of choice anymore. And that's why we're seeing that Rookout, especially for Kubernetes, is actually used 5 to 6 times as much in pre-production environments as it is being used in production, and because of that huge element, because of the fact that you can't run locally, you need to debug often, you need to debug remotely. And traditional remote debugging doesn't work for Rookout because traditional remote debugging doesn't work for Kubernetes because you can't break in a service mesh environment. Once you break a single service, then anything dependent on it is going to start timing out and things are going to go very, very, very quickly. And so you need a production grade tool for debugging and troubleshooting, and we're offering that. I would also mention that as part of Smart Snapshots, we are bringing the snapshot experience to CI and to testing. So if you're using Argo or even other forms of CI/CD, you can easily integrate Rookout into your testing frameworks to get high quality snapshots whenever a test fails, so that things are going to be much easier to troubleshoot without spending time and effort reproducing things locally, which doesn't always work so easily.
And I hope you and the team have a great KubeCon event coming up as well. But before I let you go, I just want to ask, where can folks go if they want to learn more about some of the things that we talked about today?
So if you want to learn more, you can always go to our website, rookout.com. You can reach out to us online or even sign up and try things for yourself. You can always reach out to me on Twitter, Liran_last. I'm always there.
Sounds good. Well, again, hope you guys have a great show coming up, and really appreciate you taking time out to talk to us today, and I look forward to doing it again in the future.
Thanks. It's a pleasure being here.
All right.